Welcome to part 2 of the EMERSON 8CW-334-2. I have not been able to find a schematic on it, but that's the only number on the radio. Anyways, I cleaned it best I could. I only could go in this bar. I didn't take this back off yet, and I got to replace this capacitor. I cleaned up the chassis a little bit with a cloth and some 3-in-1 oil on it to get that white powdery stuff off the chassis and the output transformer. The pointer separated, and I think it was glued once before. I have it glued up here, and I gotta wait for it to dry. Up here on the shelf, and it's got Duco cement on it. It's flipped upside down right now. So we're going to let that set probably overnight. Sorry, I can't find my pointer. So my fingers were made before the pointers were. These resistors test okay. They test here. This is a little high. This is a 3 meg and it reads 2.6, but it might be influenced. It didn't make any difference trying to turn the potentiometer. But I couldn't find a 3 meg resistor in my stash. So we're going to leave that. I'm not going to worry about it. The radio, as you heard, plays quite well. There's a 0002.0002. I looked at the conversion chart. It's a 200 picofarad. This is a 220. It reads 217 on the component checker. So I use one of these little discs that I got out of this set here that I got on eBay a year, maybe 2 years ago. I replaced this. Now, I had a hell of a job doing these capacitors because I just could not see, no matter how much I did. So I had to hook and pinch them. This is an extra long wire here. This lead would not reach there anyways, so I would have had to splice it. So I just cut them close to the component. So good old hook and pinch, especially this one here. I had a hell of a job with that. So we had to go real short with some hooks in there, and some of them I couldn't even pinch because I just couldn't get the needle nose in there to pinch them. I just couldn't see. So it's in there. Electrolytic test 1.1 on the ESR. And no hum, so I'm leaving it. And 0.98 on the other section. So I looked it up on the ESR chart for 160 volt. Well, it's 150. So it's supposed to read 1, so it's only a tenth over, so I'm not going to even worry about that. Apparently, this is the death cap. It's going to be too difficult for me to get in there. The chances of this going, these are very good caps. I've used them back in the 60s and 70s. They are very good spray caps. They are not Bumblebee. Don't confuse these with Bumblebee. These are good caps. I've got some old ones in the drawer, and they'll take the full load of the, they'll take full 600 volts. No problem whatsoever, no leakage at all. They're very good caps, so I left it in. Even though you should have a safety cap, I don't know what the value is because I can't turn it around. I tried to. But I'm giving you just a rundown here. I know it's poor workmanship, but I was very careful with the brittle wire. The rubber wire, if you don't disturb it, you're fine. I ran a new wire here see the black wire going up to pin 2 of the 35Z5. Originally, the line cord went there, and the switch, as all these radios do, switch the ground on and off, and that's wrong. So I had to take all of this out here, and the only thing I got to do now, I can't see my other terminal there. It's got to be there. I think it's down at the bottom there. The line cord hot side's got to go there, and the grounded side goes on the chassis. I hooked and pinched the wires in here because I'm not good at soldering on the chassis unless I get my American Beauty. Well, it's not American Beauty, but it's an 80 water. I tried, and it's not worth the aggravation. So what I just do is I just clip the whatever is soldered to here, and I leave as much lead as I can, put a hook in it, and I hook down the capacitor. Because originally there was a wax cap here, and it went on the grounded side of the volume control, which was fine because it goes to the chassis and still does. But there's other components that went to ground by way of this here. Am I pointing to the right one? You can probably see that better than me. Yeah, that's the new wire I put in. This originally went to ground. So all your ground was connected here, and that's wrong. So this capacitor here tests within range. The only one that's high is this 3 meg resistor right here. No, it's low. It reads low, but remember it's influenced by the circuit, so chances are it's probably high. So overall, we're almost done. Not quite. We got to replace this capacitor here. And we got to get in here and clean these tubes up. I'll probably remove this back and wipe the chassis down. You can see there's like little rust spots. I wouldn't worry about it. If it was really rusty, I'd clean it down as much as I could, and I'd paint it with aluminum paint. Or Bob could do that. He's done that on some of his other radios. And not looking bad. And I end up breaking the IF transformer off of here. It's not looking too bad. This seems to move kind of loose. I tried tightening these up, but they don't lock. They're tight as I can get them. I think there's a little rubber in here, but if it is, it isn't doing anything. But why they would suspend that like that, I really don't know. Yeah, I never could understand the tuning condenser is grounded to the frame, okay, by way of shielded wire, heavy braid. But I never could understand why they have to have the tuning condensers floating on rubber. I never could see the point of that. It's not like a vacuum tube where some tubes are microphonic. And yes, you would have them on. I've seen sockets where they are floating on like a spring type of socket. But there doesn't make sense why you would have to have the tuning condenser. But they all seem to do it, and it's always I always wondered about that. I'm sure somebody will chime in and educate me on it. Okay, so this is a show and tell. If you would not want to see the aggravation of my bad vision, trying to recap. It took me about 5 hours. Okay, yeah, this is loose here, and apparently there's rubber grommets here. But you know, all the years I've been doing radio, I don't ever remember reading about why they suspend the tuning condenser on rubber grommets. I'm sure somebody will educate me. They usually have, and I'm sure in this case they do, they have a braid that'll ground this to here. So this is already electrically connected to the chassis. So I can see insulating this off the chassis. Unless that's the case, maybe that's why this might be insulated, because I don't see these lights are not cooperative. It's dragging wires all over. No, it's not insulated from the chassis. There's your braid right there. There it is right there. So, your tuning condenser, it doesn't make sense to me why they have to be floating on rubber grommets. I've done a lot of radios, and I thought about it in my mind, but I never mentioned it to anyone. But it don't make sense. If it was a vacuum tube, it would be and it's microphonic. Yeah, sometimes in your high gain amplifiers, your preamp stages on some amplifiers would be a spring-loaded socket. You'd know the tube would move around like that. It's on cushions, usually some kind of a spring material or something. The socket is special, and and the tube just floats on a flexible socket, so you don't get microphonics, because some tubes are microphonic. But it doesn't make sense why this has to be like that. But you see where that is there. Gotta get some light on here. It's very difficult. I'm hand-holding. I'm doing a John from Arkansas, and that's not what I like to do. All right, see that? I could probably take that out and try to get a grommet in there. But one thing I'm not doing is taking the tuning condenser out. I could try to get a grommet in each one of these if I can do it. If I can't do it, we'll leave it alone. Okay, I decided to remove the old electrolytic. It's in here. I got the knob in here so I don't lose it. And these are the capacitors. I still got one on the antenna coil to change yet. So, it was drawn, the radio was working fine, no hum, but it was drawing over 800 mils, and I don't think that's normal. And I don't recall it doing that before I replaced the capacitors. I don't know. But I put a terminal strip in here, and we're going to put in some 33 microfarad at 160 volts. What was in here, this orange can, or yellow on the camera, but it's really orange, was 20 20 at 150. In other words, 20 microfarads each section. So I don't have the schematic. I can't find the schematic for this model number. So that's probably not the model number. I don't know, but I have another radio that's almost like it. I could go in the house and look at the schematic up. I put the power cord on. It's a little heavy, but the best I can do. Got some heat shrink in here. Where I spliced the two leads together, I took it off here. I got that in. It was kind of a job getting it on there. Ended up tacking it on there because I couldn't get it into around the terminal. So that's all right. It looks good anyways, and it will not go anywhere. So what we're going to do is I'm going to lay the capacitors down in the back here like this. Bring the common. See, is that going to reach? Yeah. All right. Bring the common out to here, the negative, right in here. And the hot's right here. And that should be good. So we're going to do that, and we'll come back on the video when I get that done. All right, I've got it in there. Can't find my pointer, sorry about that. So we got 33 microfarads on each side because it was originally 20 on each side. I didn't want to go to a 47 or anything like that, so I could have a medium as 33. All right, as we can see here, the only thing I did not replace yet is this 3 megohm resistor. That I don't have one in my drawer. I have a bunch of resistors that I'm going to have to, the colors are off on them. They're Chinese resistors. I think 1,000 resistors are in the little, I guess you call them pack. I don't know what they call them, but the colors are way off on them. They don't match what's supposed to be there. And they're supposed to be 5% resistors, but they're about 10% out. Probably factory seconds. I got those a couple years ago. They're nice looking resistors. So I'm going to have to dig through that, and that's going to take me a long time to replace this. So let's fire this up and see if I still get a high current draw. All right. Okay. Just want to make sure that was on. I should have looked at that. Okay. 1 to 200 volt scale. And we got the voltmeter on one section here. Common ground. This chassis, the electrolytic is grounded right to the chassis as well as everything else in the B-. The schematic that I have for a radio that looks like this has a floating B-, so it's not the same radio. I have no idea, but this is the only number I've got up here. So let's crank this up. At 45 volts, 200 mils, which is fine, but when it kept climbing. All right, we're not getting anything on the voltmeter. We are on volts. It's AC. All right, we are on DC, okay. 200 mils, let's go to 60 volts, 300 mils. All right, we're starting to climb up now. We've got to remember we have a 35Z5 rectifier. And we only have 60 volts going in. And we've got 55 volts coming out. Let's crank this up. To 80 volts. 400 or 500 mils. That seems like a little high. As I recall, I think the filaments would draw 300 mils. And then whatever the B plus draws. All right, we're 91 volts on the B plus. All right, so let's go to 90. Okay, it's coming to life. 100 volts on the B plus. That's my camera. All right. 600 mils. 100 volts. 700 mils. And that's showing 1 ampere there. There is a discrepancy between this cheap Chinese meter that I bought when I built this thing on the current versus the actual analog meter over here. But it shouldn't be drawing that much current, I don't think. So let's put it up to 117.
That's why there's equal pure Z.
120 volts on the B plus. Let's see what we got over here for current draw. Now that's not normal. Where am I here? Well, there wasn't nothing wrong with that electrolytic. I thought that was what's causing it to draw so much current. It shouldn't be drawing that much current. I don't think so. Every All-American 5 I've ever worked on is usually under a half amp. Maybe, yeah, just about that. And I felt that old electrolytic after I tested it the first time. And it was fine. It was cold. All right, we're getting a hum from the transformer over there. Let me turn this down so we don't get all that noise from this camera. That hum is coming from the variac transformer. The isolation transformer. I can feel the vibration right here. It's pretty heavy. It's not from the radio. The radio's quiet. I put the pointer back on.
Oh, we appreciate it, man. Always great.
Thanks,
all right, Mike.
Bye-bye.
Radio.com, Sports NFL. And also deep discounts on other MyPillow.
Sanitizer and other cleaning products. Should you buy them? No way, says pharmacist Ralph Ekstrand.
CDC requires alcohol to be used as a antiseptic at a minimum of 60%. Now, mathematically, when you get your 70% bottle of alcohol, mix it 50-50 with some sort of gel like Vaseline, well, that is now 35% and will work. But you will think it's working because it says home sanitizer on it.
Senator Kevin Thomas is also warning people to stay away from the products. He also wants all utilities in New York State to temporarily stop shutting off service for those who have not paid until the coronavirus situation calms down. PSEG Long Island says they will halt shutting off service. Sophia Hall, WCBS News Radio, 880.
That's nice of them. All right. Radio's working really well. except I got to find out why this is reading differently. There's a little loop of wire that you put around the sensor. There's a sensor coil that goes around the output wire, and it's dead center in that loop. But it doesn't jive with this. I believe this here. This is drawing about 1.5 amps here. If I can get my eye, I'm off camera again as always. So I don't know. That's not normal. That's not normal. But I'm gonna clean the rest of it up. And I really should test the tubes, but the tubes are good. Unless there's a shorter tube, but the radio's working fine. I don't know why it's drawing so much current, but it's working good. And I felt the electrolytics, and they're ice cold. I can't tell if the plate on this tube is lighting red. It's got a new coupling capacitor. I believe that's it right down there. It's cold. Because you got this coating on here, you can't see it. The only thing I can do is to try another 50L6 in here. I'll let this cool down. I'll do that off camera and see if that changes it. If I can find a 50L6 that I can look at the plate and see if it's lighting red. If it is, then it's got a bad coupling capacitor. But these are brand new capacitors, so I don't think that's the problem. A new old stock 50L6, no difference. Still drawing a lot of current. Alright, let's take a look at a 50L6 in the tube manual here. 5 is grid on the 50L6, 8 is cathode. I don't know if you can see that. My eyes are showing it as blurry, but I don't have my reading glasses on, so. Okay, I've got the meter on the cathode, which is not grounded to the chassis. And this is the grid here. And let's crank it up 215 volts. And see if we're getting any negative voltage. We got to go down. We're on a 200 volt scale. It's weird. Let me see. Maybe it went over range here. Let's see. Negative 4.6. Negative 5. Okay, let me take this off and put it on the chassis. That's the transformer you hear, and I can feel the vibration here. It's not the radio. Well, obviously, am I on? Okay, I don't know if you can see that or not. I can never find a pointer when I want it. This is pin 8 is the cathode. So this is obviously the coupling condenser that I had to add leads to. So I'm not really getting a negative voltage on that reading from the chassis. Well, it's jumping all over. It's the lowest I can read. So we're back on the cathode itself. In other words, this last test I was testing from the chassis, the negative lead of the meter, to the chassis, but this time I'm going right to the cathode itself, and we're getting 5.29 volts. .3 if you want to go down there. Alright. It's not tuned in. The radio's working. Like I say, I got that 3 mega ohm resistor right here to change. I think that's it. And this is going to conclude this video. The rest, I just got to change that capacitor on the back of the coil, antenna coil, and change the that resistor. Do that off camera and clean the rest of the chassis in the middle here. Let's just wipe it down, put a little 3-in-1 oil on it. Clean the tubes that I couldn't get at. But it's drawing a lot of current. I don't know why, but it's working fine. Capacitors are cold. So it's not the filter capacitors. But drawing that much current, that don't sound right. Okay, I did that video that you just watched yesterday. Today, this was bugging me as to why this thing is drawing 1.5 amps. Well, we found out because I just cranked this thing up. There's nothing plugged into the isolation transformer. Isolation transformer's on. You listen to this thing hum like a banshee, and we watch the amp meter. Put in 117 volts. We're drawing 800 mils here, and we're drawing probably 1 amp. It's hard for me to see that. I'm going to say 1.3 amps right now. So what we're going to do now is we're going to unplug the isolation transformer from the variac. This don't need an isolation transformer anyways. It's got a polarized plug-in cord on it. Alright. Let's crank her up. Let's go right up to 117 volts. The current is 200 mils. I knew I wasn't losing my mind. There's where all the current draw is right here. We'll let it warm up. It's drawing 200 mils.
To gyms, health clubs, daycare centers, and movie theaters to control the disease.
All right, let's turn that down. 200 mils. And I can't even read this one. So that's... I knew I wasn't losing my mind. I was going crazy here, and I really didn't have to replace those electrolytics, or this electrolytic here. I didn't have to. But it's done, so, you know, we don't know how long this would have lasted anyways. Now I was scratching my head, and I thought maybe the output tube the grid was positive. Well, you saw that on the video. When I measured from the cathode to the grid of the 50L6, I was getting about 5.5 volts, roughly, negative, but wasn't getting any bias when it was, the negative lead was connected to the chassis. So anyways, we know the radio is fine, and it's drawn 200 mils. The filament string is 150 mils. That's what the tubes are drawing for filament current, and the rest is the B+. Well, there it is, folks. So the answer is, do not measure your current with the isolation transformer before. In other words, put your amp meter after the isolation transformer. The way I have this set up, when it was over here, I had my dim bulb here to the isolation. The dim bulb was in here, and I ran it off the dim bulb, and then when I flipped the bypass, I was coming out the isolation transformer. So in other words, I wasn't using this in conjunction with this. I was using this in conjunction with that. So a transformer will draw current even though there's no load on it. Good thing to remember. This was driving me crazy, and then I thought as I was editing this video, this radio can't be drawing 1.5 amps. There's got to be a major problem with the radio. If it was, 3/4 of that current was being drawn from this. So we know that now. This concludes the video, and Bob will be happy. The radio works. And this is it. This concludes the video. Part 2 is the end of this series. Got that little cap changed in here. You can see it down there. Thanks for watching. Entertaining, wasn't it? No? Oh, okay.